Good afternoon, everyone. I hope you had an enjoyable lunch. You're nice and full and have no more distractions, and you can just listen to me speak about generated code for however long. Just quick up front, I thought I was going to be giving a lightning talk today, and so I planned for about an 8 to 10 minute talk, but now I have 30 minutes. So you'll get a little bit extra details, but bear with me. Some of it might be a little bit more polished than other parts. We're just here to have fun, though. A little bit about me. I'm on the developer experience team at Meta. I've been here for about 3 years and have worked on a variety of systems, from continuous integration to this code generation stuff that I'm about to talk to you about today. But a little bit of background before we get into this story. I want to give you a little bit of background about how we do development at Meta. I'm going to be focusing on the monorepo that hosts our website and web server deployments. This repository is mainly JavaScript and Hack code. Hack being a variant of PHP that we've developed in-house. In this repository, we really like to take a developer experience first approach to how we grow and evolve the repository. So we do a few interesting things. One, we don't have a build. Hack is an interpreted language. JS is an interpreted language. We don't like to have to compile code to be able to run things. We believe you check out the repo, you start using it, nothing else. We don't have any explicit imports or explicit dependencies in our Hack code. So you want to use some piece of code, you can just go ahead and use it. You don't need to manage this giant list of dependencies at the top of all your files. We also have a monolithic release. No individual teams, products, or anything else needs to configure their continuous integration or their deployments. You want to write a new product, you hop into the repo, you start writing code, it'll get out to prod whenever you merge your code into the repo. I also want to clarify what I mean by generated code when I'm talking about this story. So when I'm talking about generated code, I mean generated source code. Code that you could imagine writing yourself, except in this case, it was generated by some script or command that you ran in the terminal. We also do a couple special things where, one, we sign the generated code. We take the hash of the content and we save that, so we know when users try to modify the generated code themselves. We really don't want them doing this. If it's generated, we assume it's been generated correctly. Don't go and touch the generated code. That's room for error. And the last interesting thing I think we do is we check this generated code into the repository. So when you check out the repo, you don't need to rerun the code generation command. It's already been generated for you and checked in. You just hit the ground running. So generated code is typically a solution used by framework developers to improve the developer experience for their framework. I think this is best explained with an actual example. So I'll go with something simple with like request routing. You get a web request, and you want to figure out which class to run the code for that request. Pretty common problem that we've all run into. Different frameworks out there handle it differently. At Meta, we have a framework where you define a single class, you define the root for that class, and as well as some other things about parameters, etc. You run the command. This code generation command does a few things. One, it'll add your root to the URI map. This is a giant generated file that hosts all the roots that people have set up and maps them to the classes that need to run that code for that request. It also generates some typed classes for other people around the code base to interact with your root in a type-safe way. And so we have this solution of generated code we discovered years and years ago, and we start to use it for a lot of things. We start generating types between languages. So, for example, thrift or protobuf, which is a very common thing you want to share some schema between two languages. We start doing other interesting things like generating tests. You integrate it into some framework, you run a command, and now you have a baseline set of tests to guarantee correctness for your system. That's pretty awesome. We do things like this kind of pseudo-cache pre-computation with our generated code. That is, for example, the URI maps. You could imagine we calculate them on the spot for each request. You go through the entire code base and find it. But we store it as code. You could do things like find all subclasses of this class, instantiate them, call this function, and then store the results as code. That way you don't have to do it at request time. And so what we really noticed here was people started really, really loving this generated code solution. They started using it for everything. In particular, we have big frameworks and small frameworks. So big frameworks like the URI maps. We have an ORM framework that uses generated code, a logging framework that uses generated code. But these smaller, more product-specific things also began to copy these solutions because that's what the big frameworks do. That's what's approachable. That's what people know. We should do that same thing. And so people begin further using generated code, expanding on it, thinking like, how do I architect my code to use generated code? And we, the developer experience team, see, okay, people love this, and the experience is not great. We need to support it. We need to scale it. And so we really worked on two things: how people, the average developer, interacts with generated code, and how people create new generated code. So when it comes to interacting with generated source code, there's a few things people need to keep in mind. One is when you have certain files that are like really big and hot, they can get modified very often. You run into lots of merge conflicts. Now people having merge conflicts in generated code, no one likes merge conflicts. We can auto-resolve those for you now. You know, you run into a merge conflict, you run the script, it happened in the background, awesome, cool. Sometimes people were forgetting to run the code generation scripts. So we started adding checks in our continuous integration. Did you run the correct code, run the correct command? As more and more commands were being added, you're like, there's too many commands, I don't know which one to run. So we created a one command, it looks at what files changed, and it will figure out the correct subcommand to run. And we also started making it easier to write and create new generated code. So for these framework developers, how do you make sure they're creating a good experience by default? Believe it or not, creating generated code and writing these scripts and subcommands is really hard. I mentioned before how we have no explicit imports or dependencies. Well, that comes with a pretty big trade-off. When someone, let's say, deletes a symbol or deletes a class or depends on something in some weird way, how do you know when to regenerate your code? So we noticed a lot of people were making bugs in when to regenerate their code, and so we built a framework that simplified this for them. We also did things like implementing incremental code generation. So a lot of these subcommands would look at this entire giant repo, find all classes or subclasses of some type, do some kind of computation, and this was kind of slow. And so we were like, okay, what if we looked at just the files that were changed? Generate the code just for these small bits, and that helps speed up the code generation process. And so we keep going and going and going until, oh, I hit the back button, my bad. Yes. Until we reach what we were at a couple years ago, which is generated code has become a daily part of our developers' lives. Every single day they need to run code generation multiple times per day, and it is still the biggest pain point for our developers. We get common complaints. It takes so long to regenerate the code. We have this incremental code generation. We've made it relatively bug-free, but people are still giving complaints. Broken code is getting into the main line. I talked about before merge conflicts and how we auto-resolve them. This ended up appearing like your rebasing diffs were being really slow. And so we took a step back. We looked at the problem, and we were like, okay, generated code isn't scaling. This is not the correct solution for a lot of our problems. Can we do a better job? And so we figured out a few things. One, a lot of people were using generated code because there were some deficiencies in our other frameworks. I mentioned before how we have generated tests. Well, why are people generating tests that follow some weird pattern? We can improve the testing framework. You can write one test, define how this test will work for all of these different cases, and then not have to generate each individual case. And then the infrastructure can handle checking individual classes and cases of that test. I mentioned before how we have these kind of like pseudo caches where people are running some kind of pre-computation and then saving it as code. Well, why can't that be an actual cache? And so we built this really smart caching system that watches the file system, and as you're changing your code, it's regenerating the data and storing it in memory. And so we no longer need to materialize this data as code in the repo. It's just there by default in the background, no commands to run. And perhaps the most interesting thing we did, because we own Hack the language, we were able to improve the language to make it more expressive. Generated code, we noticed, was actually a sign that the language itself was not expressive enough. We saw people were doing things where dependent types would be really useful. For example, where the output type of a function would change based on the input type of the function in a way that's not handled by like normal generics. So we created this thing called enum classes. You can find out about it later. I can talk to you about it later. And we worked with the Hack team to implement this feature and roll it out to the repo. And it helped us eliminate a lot of generated code. And this is still an ongoing project for us. We've been rolling back or deleting generated code for about 2 to 3 years now. And we've made a lot of progress. And we have a lot of progress still to be made. There are a few key takeaways that we learned through this multi-year process that I think are particularly useful. One, small frameworks and new frameworks are going to copy what the big guys are doing, right? You kind of have this novelty budget, I think compiler and language people think about, which is if you do things that are too new, people aren't going to adopt your framework because it's too different. They don't want to spend that extra time learning. So people do what's familiar, which in this case was generated code. And as the second point mentioned, it wasn't the best solution for a lot of people. This is hard to write, difficult to maintain, but it's a really powerful tool, and people were using it when they had alternatives, such as building new features into their frameworks or architecting their code in a different way. And so because we made generated code so approachable, people opted for the more difficult, complex solution, even though it wasn't the correct one. And lastly, once our generated code, which was at first an actual pretty big win for developer experience, once it grew into a problem, we had to step back, reevaluate, and figure out for these individual problems that people are using this kind of silver bullet approach for, can we create a more optimized or optimal solution for these specific problems and create a better developer experience that way. Thank you. I will be taking some questions.